Now that we're dealing with complex numbers, we can talk about solving equations with complex answers. We didn't have this before, so anytime we ran across this, we could get no solution, one solution, or two solutions. Now, there's no way we can get zero solutions. We can get one or two solutions now with every problem. That's the nice thing about this. Now, before seeing a problem like this, we would use the square root property. So the first thing we would do would be subtracting 4 from both sides. So this is now x squared equals negative 4. Now this is where it gets a little weird for us. This is really the square root of both sides. Now again, when we ran across this square root of negative 4, we would say, oh, no real solution, so we're done. Now we don't have that luxury. So this is now really x equals plus or minus square root of negative 4. And now we can actually handle that. So that's plus or minus I square root 4, which x equals plus or minus 2i. Now this is both of our answers, and I'm going to write them separately just because in most cases that's how they do it for the homework. So there would be the two answers for this one. Now, on a test, I would be okay either way. Either answer would be good for me, but for the homework, you probably have to separate them. Okay, for the next problem now. This here, we could try to factor it. Then we would realize that it's not going to work. So then we would say, okay, what else can we try? I'm going to do completing the square on this one, just so you can see a little more you can get a little more exposure to it, and you get another example under your belt. So I'm going to minus 10 from both sides, because this is how you start with completing the square. I'm going to get an x squared minus 6x equals negative 10. And then I'm just going to have to add a certain amount to both sides so that this x squared minus 6x becomes a perfect square trinomial. So I'm going to take half of b and square it. So that means I'm going to add, that's going to make that negative 3 in there. And when I square that, I'm going to get 9 positive. So I'm going to have to add 9 to both sides. So on the left side here, I get x squared minus 6x plus 9. And that's going to equal negative 1 when I add those together. Okay, and this on the left side then is going to be x minus 3 squared once I factor it. And that equals negative 1. Now once I get to this step, I square root both sides. So square root. This is really going to be x minus 3 on the left side because those cancel each other out. And then over here, square root of negative 1 is I. I don't really have to pull an I out. It's just I. Done. By definition. Oh, what did I forget? I forgot the plus or minus. Don't forget about that. So plus or minus I. Okay, so we're almost done. Not quite, almost. So now on the left, I really have x minus 3 equals plus or minus I, which means I have to add 3 to both sides, which I can't add those together because one's an I and one's a number. So I'm going to get x equals 3 plus or minus I. So just keep in mind how those separate. I'll write them just for the sake of getting used to that. Hopefully that's okay for you. But again, remember, I said this answer would be okay for me on a test. That would be full credit. So just know that. Okay, last one here. Now this one is x to the 4th equals 16. This one here is a little more complex than we would think. This one here would be easier maybe by square rooting both sides, because normally we would think of fourth root, and then I'd end up with a 2 here. But that's not the only answer. So that's where it gets a little interesting. So I don't know if I want to just square root here. One thing I can do is I can subtract the 16 from both sides, and think about the idea of factoring. So this is going to be x to the 4th minus 16. Because remember here, I have a possibility of 4 answers because my highest degree term is x to the 4th. So this equals 0 here. So I can factor that. That's a difference of squares because It's difference because it's minus. And then x to the fourth is a perfect square because x squared times x squared. When I multiply those, I get x to the fourth because I add my exponents. And 16 is 4 times 4, so it's a difference of squares. And I can write this as x squared plus 4, x squared minus 4, if you didn't remember. And that equals 0. Now, we'll handle this part first because that's easier. That's really x squared equals 4 because I moved it over. Well, let me write it out first. X squared minus 4 equals 0. Or x squared plus 4 equals 0. Now remember, I'm just taking each of those pieces and setting them both equal to 0. Because when I times them, either this is 0 or that is 0. Because I get 0 on the other side. So that's why I did that. That's just a 0 property. So anyways, so now with this side, I'm just going to add 4 and add 4. I'm thinking the square root property. So this is going to be x equals 4, x squared equals 4. And then I square root both sides. And this is going to be x equals plus or minus 2. Because remember, when I square root, I got a plus or minus. Okay, now for the other one here. This one here is a little different. I can do the same thing. So x squared equals negative 4. I square root both sides. Now on the left side, I get x squared. And on the right side, I get I. Before I write the I, though, I'm going to do the plus or minus. I don't want to miss that again. Square root of 4. So then x equals plus or minus 2i. So this is actually 4 answers here. So there's 2 here and 2 there. And again, if I looked at the original problem and just said, hey, I'm just going to fourth root both sides, I would have only gotten one of those answers, and that would have been this one up here. But I can't, so I have to be a little careful with those. So in essence, if I'm dealing with an x to the fourth, I should be looking for sometimes more than one answer. Not always the case, but it's a start to kind of get me in the right direction. And that's why I thought about the idea of factoring for this one. And it paid off. So there's our answers for solving in the complex number system.